Okay. So, we at Marel, we started our IoT journey just over 1 year ago, when we started to look into predictive maintenance with the help of IoT and new cloud technology. Today, I would like to share with you our experience so far, what we have learned, and how we have approached it. But maybe first start here. Why did we start to look into this new technology? The main driver has definitely been Industry 4.0 and what that revolution is going to bring us. And that is not only going to be about lowering cost or improving efficiency. We are actually going to be transforming manufacturing processes, both for us at Marel and our customers. A part of our vision at Marel are smart factories. And there we are going to be taking automation to the next level. We will have fully connected, flexible systems that will be using streaming data to adapt to changing demands. So in the end, we will actually have self-learning and self-correcting systems. And we see this, what we are doing now with predictive maintenance, a step to bring us closer to that vision. But let's start to look at the different maintenance programs we have today. First, we have reactive maintenance. And that means that we are fixing things after they break. So we are using the components and the part to their full limit. And this type of maintenance is very costly, it's unscheduled, and it will always lead to downtime in production. And that is why many of our customers are today using preventive maintenance. So there they are using fixed maintenance schedules, which recommend replacement of parts at a certain interval. So in that case, we are actually making the repairs before anything breaks, but we are, however, doing it too soon. So like the parts are still in their usable condition. So what we will try to do now is to move over to predictive maintenance, where we can actually find the optimal time to do the maintenance. And with new technology, we are able to connect to machines, we are able to use both historical data and real-time data to do our analysis, create predictive models, so we are able to predict the failure before it happens and actually find this optimum time to do the maintenance. So the main benefits of preventive maintenance for our customer is definitely increased uptime. Most of the machines we produce at Marel are inline, meaning that they are a part of a bigger production line. So if one machine breaks, the whole line is down. And that can have huge consequences, even though it's just for a short amount of time and is very costly. With predictive maintenance, we are also able to lower the maintenance cost by reducing the unscheduled, the unplanned breakdowns, and also by reducing the unnecessary repairs and part replacement. So by actually finding the optimal time to do the maintenance, we are able to minimize the maintenance cost. We are also able to better handle the scheduling of the maintenance, because now we know in advance when a part or a machine is going to break down. For example, we are monitoring a motor, and we know from our predictions models 3 weeks in advance if it's about to fail. So that gives us plenty of time to make necessary arrangements. And at last, it also gives us just more knowledge and awareness of the machine status in real time. So what are then our biggest challenges? When we started to look into this just over 1 year ago, we saw some studies that said that around 80% of industrial IoT projects become a failure. And the main reason is usually the complexity. These initiatives, they often look really good on paper, but when you actually start to implement it and scale it up, it becomes very complex. And that is why it's really important to always focus on the value we're bringing instead of just a new and cool technology. For us at Marel, we also need to think about our customers. And this doesn't matter in this program where we are trying to create new services, or if we are building new machines or new software. If we are not delivering to our customer increased throughput, more uptime, improve the yield or efficiency, we are not going to get to put new solutions into their factories. So we really need to take these things into consideration. So what do we then need to be able to realize this, to really be able to move into predictive maintenance? First of all, we need data. And it's not just data. We really need to be able to translate the data into useful information. And it's often when you start this, the most easiest data collect is probably not the thing that is going to give you the most value. So we really need to identify the right data we want to collect, and then we need to be able to make sense of the data. And here we really need to have data scientists working with us, with people, our specialists, that have that domain knowledge on the machine to be really able to develop the predictive algorithms we need together. We also need, of course, the cloud platform. We need to be able to get the data from the machine and sensor to the cloud and have it accessible. So, and we are going to have high volume of data because we are thinking we are going to connect machines all over. And for example, one of the machines we have connected today is sending around 200,000 messages. And that is just one machine. So we need to prepare for this big, high volume of data. And we are also going to have different type of data that we need to manage. And we split it up into 3 main categories. So we have hot data, which is data we need to analyze quite frequently, so it's constantly changing. Then we have warm data that we need to analyze less frequent, but still on a regular interval. And then we have cold data. And there we just want to have all the history, so we can access it later. And that is also our main platform for our data scientists to be able to do the research, to really create the knowledge we need. And then we need to be able to store all this data. And finally, we need to build a scalable solution. Because like I say, we are not building a cloud platform that is only to support one factory and the machines there. We are going to take this all over the world and connect thousands of machines. So it needs to be done in a scalable way, so when we're building it, the infrastructure must focus on automation as much as we can. And finally, we need the business. In this case, that is service. And we actually need the business to be driving these changes, because we are going to be changing the way we operate and even our business models in some cases. So it is really important to get buy-in from management throughout the company to really make this into a success. And then it's important to identify what is the value for Marel and what is the value for its customers. So now I want to go a little bit into how we have been approaching it in our journey. So we split this into these 3 work streams. We have application development, cloud platform development, and service development. And within the application development, here we are really focusing on the data. So what kind of value can we bring? Can we actually build those prediction models we need to be able to say when a machine or a part is going to break down? In the cloud platform, there we of course need to build the IoT cloud platform itself. We need to be able to get the data from the machine and sensor into the cloud. There we need to be able to process it and actually run our algorithms. And then we have service development. And here we are going to think about how can we actually wrap this in a product? How are we going to sell it? And how does it then fit with our current portfolio? And as well, we need to think about our business processes. How will that affect them? Do we need to adapt or change? But before we start these streams, we want to do pilots. And in the pilots, we really want to experiment whether there is actual value in this before we invest in an entire development of a program like this. And that is what we did. And in the pilot, the main focus is, of course, can we find this value? What can we actually do with the data? And I want to tell you a little bit about how we set it up. And of course, we start with a team. And in a project like this, we think it's really important that people that are working on it have 100% focused only on this project. So it's not a side project for anyone. This is complete focus. And we also knew that we wanted to do it in partnership with a customer to get feedback as quickly as we could on the solution we were developing. So we had a team, and that consisted of a project manager, 2 data scientists, and 2 programmers, working together with one pilot customer in only 6 months. And we wanted to do it in an agile way, and we were focusing on iterations. So we had an idea, we designed it, built it, took it to the customer, tested it, got feedback, and improved. And this way we were able to learn really fast. We also focused only on one machine in the pilot. And the machine in question is an X-ray machine, which we use to scan products for bone and other contaminants. And now I want to tell you a little bit what we achieved in this pilot. So one of the first questions we asked ourselves was, can we predict failure of the most critical components? And of course, the first question then is, what are the critical components of the machine? So the first thing we did, we sat down with our specialist about the machine and service specialist, and it soon became clear that the X-ray sensor was one of the most critical parts of the machine. What was interesting about this is that this component, it degrades over time, even though it's not being used. So our customer, they are not able to have it on stock. So if it fails, there's always downtime involved, because we need, as Marel, to ship the component to the customer, send a technician with it, and that to replace it, and that always takes at least 1 or 2 days. That means the machine cannot operate in that time. So we thought, okay, if we can do this, this is definitely going to be a huge value for us. So we had one machine now connected, so we were able to get data. And on top of that, we had access to historical data as well. So our data scientists could now really start to dig into the data and start to build our models, the prediction models we need, which they did, and we deployed the model. And it was kind of strange the time now. Now we're kind of in waiting time. We had the model up and running, we had one machine connecting and monitoring the sensor. And we saw that the sensor was in pretty good shape. There was no indication of failure in the future, but you were still kind of hoping for a failure because you really want confirmation that your model is working. So we were waiting, and then it happened. There was a failure at another customer. We said, okay, can we maybe get the data from there, run it through our model, and backtest it that way? And that is what we did. And that is the result you can see here on the screen. So that sensor, it failed in February, but already in October, our model predicted it. So this was our first confirmation that this was working. We could actually do this. And I remember we took this to the customer, and that was also when we got his real buy-in of the project. And he immediately said, please connect all my machines to the software. So we went from having one machine connected to having 4. And like I say, this was just the first confirmation, and since then we have had more, and today we can say in great confidence that we can predict the failure of this critical component with 3 months in advance. Another question we wanted to explore in the pilot phase was to see if we could actually use telemetry data to detect anomalies. And I want to walk you through an example of a data that we started to monitor. And that was the temperature of the X-ray sensor. And we knew that the temperature must not go over 29 degrees. If it does, it will start to damage the sensor and eventually it will be ruined. So we started to monitor the data and we set the threshold at 29 degrees. Soon after we started monitoring, we got the first alert that the sensor was overheating, the temperature was above. So we contacted the customer and asked, okay, if there was some logical explanation, and we didn't see anything. So we decided, okay, we have the machine connected, let's look more into what more data do we have. And then we could see that the cooling effort was working at maximum capacity. So this gave us more indication of the problem, but still we hadn't found the root cause of it. So we looked in even further. And we saw that the current from the machine had actually dropped. So here we found the root cause. So the cooling unit was just that it needed to be replaced. So here we were able to detect that before the sensor was damaged and replaced it. But it was kind of strange that this was the first time a cooling unit like this had ever been replaced. It's a part of the sensor, and in the past we have always replaced the sensor itself. And because we weren't monitoring these things, we didn't know when it was being damaged, we only knew when it was ruined. And it cost way less to replace only the cooling unit than the complete sensor. So here it is great value for us to be able to detect this at this stage. So we have built the logic now into a system. So if this happens in the future, we can trigger it, we can visualize it, and we can give our customer information on the corrective actions he needs to take to be able to solve it. So in the pilots, we have actually now confirmed that we can actually monitor critical components like the sensor and predict failure of it. We also proved that we can monitor the telemetry data to detect anomalies. And on top of that, we even got confirmation from the customer that he sees value in this, that he would buy this solution from us. So now we are ready to invest in the complete development of a program like this. And what this pilot will also do, it will speed up the development time we need within each of those tracks. So in the application development, we can use what we did in the pilots, build on that, we can improve our models, we can add more logic to the system, more rules, and start to monitor other critical components that we want to monitor in a similar way and be able to predict failure in the future. For the cloud platform development, we can also use the pilot to really set the requirements. So because there are so many possibilities you can do with a cloud platform in the future, but when you're building it in the beginning, it's really important to have clear focus. So you're only in the beginning building what is needed for the application. So you're really keeping a narrow scope. And for the service development as well, there we can use the information from the pilot because we have indication of the value we can create. So we can use that to help us define the product, how we're going to price it and sell it. We can then, in this work stream, work together as one team under one leadership, building our next release we want to take to the market, which would then be the MVP, our minimum viable product. And by setting this up in this way, where we have the pilots, we are able to speed up the innovation, and we are more confident that the end solution will actually bring value to our customers. Thank you.